Hi guys, and welcome to the very first in our installment of our LinkedIn Live series. If you're new, the purpose of this series is to effectively have a deep dive into the industry, where I'll be hosting a series of interviews over the next couple of months, sitting down with some key people in the industry and having a good chat, basically, learning a bit about them and sort of what they do. Naturally, I'm here with Vicente this morning. And Vicente naturally will be speaking about facade engineering, his area of expertise. Before I dive into that, let me tell you a little bit, I guess, about myself, sort of who I am and what I do. So I specialise in forensic structural engineering and building envelope consultant recruitment across the states, really, with a focus on DC, Virginia, Maryland, North Carolina, South Carolina, and Georgia. And I guess, yeah, no better way than to kick off the series with Vicente. So yeah, Vicente, lovely to sit down with you this morning.
Hi, Sarah, how are you? Well, thank you for the invitation. We are very excited for this opportunity, and we're also very excited of working together with you for several years now. So thank you.
Absolutely, no worries. It's a good partnership, and we sit down often and have good chats about the industry. So only right that we share it with everyone else, right? So yeah, let's start with yourself. And naturally, tell me about yourself, your background and your expertise.
Well, I'm a civil engineer by training. I studied the undergrad in Mexico in the Monterrey Institute of Technology. Some people decided to call that school the MIT of the South, because it's Monterrey Institute of Technology. And it's a very good school. And CDC hired me as soon as I graduated from there. I've been working with CDC for about 17 years now. And then while working at CDC, I also did a master's degree in facade engineering in the University of Bath in the UK. So very close to you.
Yeah, not far at all.
Yeah. And then ever since, I have continued to work in the different aspects CDC offers. As you may know, CDC is a building, it's a company where we do engineering, drafting, consulting, design of building enclosure systems, not only the facade, but the entire envelope, roofing, waterproofing, below grade waterproofing, everything. So we cover the whole envelope.
Yeah, no, awesome. And such a rich history sort of in the industry as well, naturally. How did you find your experience in Bath anyway, over in the UK?
It was just 1 year. It was a very intense program, very good program. And in that program, it exposed us to the different aspects of building enclosures, mainly the facade. It went from fabrication, installation, design, facade engineering. So it was quite complete. So it was a good time.
Lovely, love it. I've never actually been to Bath, but I should visit. Should go down.
Yeah, it is a nice, beautiful town.
Definitely awesome. And I guess that leads us really nicely onto overall, what is facade engineering, and how did you specifically get into that and find that sub niche, I'd say, in a niche?
Yeah. So facade engineering, it's the actual engineering of the facade, right? As the name says. But there's different aspects that you can engineer and different aspects that you can and must take into consideration when designing a facade system. The four key elements or the main components of this facade engineering aspect is structural. The second one is thermal. And then the other two is air and water performance. Of course, there's different aspects with or subcategories amongst all these major four categories that we identify. But mainly, that's what you need to focus on. That's what you need to consider when approaching projects, so that holistically you can design and take most of the items in consideration while you're doing the design. And I say most because there's always stuff that happens down the road. Things get changed. Different systems or components get value engineered. So that's when you have to switch gears and then focus on different areas again. How I got into this, it's as I mentioned before, I graduated from civil engineering with a major in structural engineering. And then CDC hired me. So I started doing the actual engineering, the structural calculations for different facade systems. So I was not doing the full facade engineering. I was just doing the structural portion. And there, I mean, doing structural calculations for curtain wall, window wall, precast panels, natural stone, glass railing systems, like all different kinds of systems. I was only focused on the structural performance, right? And while doing this, you are only like your eyesight is just there. You're not paying attention of how the water it's managed through the system. You're not paying attention of different things, like if you specify a fastener in X or Y location, you're not necessarily thinking if that fastener is going to go through and be an issue for water performance and penetration. But then as years went by, then I started getting into the other aspects of facade engineering, and now I pay attention to everything. And with this idea and with this learning curve, I have helped throughout the years others at CDC to also look for these other type of things and not only focus on the structural if we're doing the structural portion.
Yeah, wow, that's interesting. I think it's yeah, I mean, correct me if I'm wrong, but most definitely a discipline that you learn, especially through experience as well, you know, in the field and seeing, you know, what happens over time. Would you say that's right?
Yeah, no, that's right. That's right. And there's a few schools that have programs that teach this in the undergrad, but it's more like building sciences and stuff.
Yeah.
There's, to the best of my knowledge, not a comprehensive program that covers all aspects. There's better ones now, but back when I was selecting my undergrad, there was nothing. But even if there had been, I don't know that I knew that this type of industry existed back then.
I know it's crazy, and I often speak to people that have no clue. That leads quite nicely actually onto a question I thought of. How would you, I guess, advise people, potentially people watching who want to get into facade engineering and consulting but don't necessarily know how? What route would you suggest to people? How would you advise to get into the industry?
Well, I think it's like a natural progression of knowledge and levels of expertise. Because when you're in school, I mean, most of the people think that they know what they want to do for the rest of their lives, right? But then things change, and then you switch and stuff. In my case, I knew exactly that I wanted to do structural engineering since I was very young, and I never changed from that. But what did change was the level of knowledge, the level of expertise. Because first, I was like, well, I want to do bridges. I want to design bridges, and then as I progressed, then I got this job offer from CDC, and it's only focused on the facade systems. So I went from thinking, when I was choosing my career, it was like bridges, building structures, like huge things, right?
Yeah.
And then when I get to CDC, we're looking at number 12 fasteners, 1/4 inch fasteners. Those are very small in comparison to what I had in mind. So as you progress during your career, I think you find different aspects that you like or enjoy doing the most. And I think it's a natural progression, because this is very specialized, and some people just fall into it, and some people just love it. Some people don't. In my case, I have liked it almost instantly since I started doing it. So yeah, I'm still here.
I love it. Love it. And I guess you're in the unique position, right, that you've seen actually this subsection of the industry across quite a few different states, naturally starting your career down in Texas, now based in sort of the DC area, but with an oversight over New York and a good knowledge of the North Carolina market as well. From that perspective, you know, it's, of course, I guess the infrastructure is different across multiple different states. You know, in New York, you have extreme high rises, whereas in DC, of course, all the buildings are sort of capped, I'd say, at a certain height. What would you say would be the main differences, if there are any, to your approach to facade engineering across different states?
Well, as you know, CDC has offices all across the US. We have about 15 offices from the West Coast through the East Coast. We even have offices in Hawaii. So it's quite diverse, and it depends, as you said, on the market, the demand for the different products in the different markets. Right now, in general, there's a lot of demand for residential high-rise buildings. and not so much for office space for obvious reasons, right? So that's what we have seen through the last couple of years. But market-wise, also it's the use of different products. There's different products and materials, different brands, different manufacturers that are preferred over others in the different markets. So it's quite unique, and it's also it's I guess it's just like dealing with different clients, right? Some clients you get to learn through the years that they prefer doing or designing buildings in such a way, and it takes you time to develop that relationship with them and understand their priorities and what they need. But in doing so, you also have to learn how that market operates, because although Virginia, DC area, it's very close to New York, the use of products and manufacturers on certain specific areas, it's very different. And if you compare East Coast with West Coast, there's like a huge difference with the preference of materials and manufacturers that are using the East Coast from the West Coast. So it is different, it's challenging, but that's why we have experts in every market. That's why we have these offices is strategically located across the US, so that not one person knows it all. So that's what brings the energy and the expertise to CDC, the people.
Absolutely. And as one person doesn't know it all, that means there is absolutely, you know, that chance to learn and grow from each other, which is the best way of doing it, you know, learning and growing, which is awesome. Cool. Moving on, I guess, to some cool projects. You know, something that entices people is often hearing about, you know, naturally how the facades have been involved in facade engineering and some awesome projects. I happen to be sitting right next to the Walkie Talkie building. It literally is there, strategic location. Naturally, it was quite famous with the Walkie Talkie building. Tell me a little bit about that. What happened in the case of naturally when the facade was burning cars, effectively?
Yeah, that's quite fascinating. I mean, from the nerdish point of view, it's fascinating because that building, it's concave in two different planes, the vertical and the horizontal plane. So if you cut a section through it, or if you look at it from the side, you can see a natural curve on the facade. And if you look at the building from the top, there's also curvature. So these compounded curves create what is called, or what some people have called the death ray, which is not more than all the sunlight concentrated in a focal point. So all the light from the sun reflected from the building facade, from the glazed facade, concentrated and reflected onto one focal point, which is what was causing the cars or the different things to melt. So yeah, there's some pictures out there, if you just look it up, that are quite fascinating. So yeah, it got famous. There's another case, also a famous case for the death ray in Las Vegas.
Really?
And yeah, and that one is also fascinating. I mean, it's unfortunate for the building owners, but from our field of view and expertise, it's fascinating. Now, before those two cases occurred or happened, we had come up with a software that actually can predict and quantify the amount of energy that is reflected from the building facade onto the environment, back into the environment. So we had this service going for a couple of years before this happened. And then when this happened, then we started getting the calls, and then this phenomenon started to get a lot of traction and attention in the different markets where it was occurring, like in London, like in Dallas, Texas, like in Las Vegas. So there were a lot of concerned architects, designers, that they didn't wanna, they wanna know if their building had the potential to be the next death ray. So yeah, we still perform this service. Fortunately enough, there hasn't been another critical case like the Walkie Talkie tower, but people know and people remember those extraordinary cases. So our services is still being used, and we can say that because of our service on a few projects that we have already performed, the building geometry was changed because we found that there was a potential issue for being the next death ray. So it's quite a useful tool.
Yeah, 100%. So useful and really interesting, really, really cool, fascinating, as you said. I didn't know about that case in Las Vegas. Wow, what building was that? Do you know?
It's called the Vedara, VDARA.
Okay, I'll have to check it out. Check it out. Okay, and I guess that leads quite nicely on to I guess the future of facade engineering, you know, with a focus absolutely on climate change, you know, and global warming. How do you think that facade engineering is impacted by climate change, if at all?
Well, I think you could also see it the other way around. The lack of facade engineering impacted climate change. As you may know, energy consumption by the buildings, it's on top of one of the major contributors to climate change. It burns a lot of resources. It requires a lot of resources to fabricate, to install, to ship, to handle. I mean, it's a lot. It's a ton of embodied energy that goes around designing and fabricating these systems. And earlier, there was not a lot of attention being paid, and earlier, I mean, in the 60s, 50s or so, there wasn't a lot of attention being paid to the overall performance of the envelope. There has been a lot of advances in the performance of glass, in the performance of different systems, but there has been some lack of understanding or design to holistically bring all the systems and components together. One very good example of this is that some people think that triple glazing is the way to go for energy performance. Well, we did the preliminary engineering, facade engineering on a project here in DC, where the energy modeler said and requested that we used triple glazing. And we review their assumptions, and the U value that they had assumed was very, very low. And we look at the systems that were available and within the budget, and we just told them, it's like, there is no way that you can get to this U value. And they said, well, but we have triple glazing. It's like, okay, well, we'll do the comparison, we'll run the numbers, and we'll let you know. Sure enough, the frame of the curtain wall system wasn't thermally broken. It was just thermally improved, which means that the passage or loss of heat was still there. So with double glazing and triple glazing, the difference, the delta in the U value for double and triple glazing was not much. You would think, because just going by if you just look at the performance at the U value of glass, triple glazing to the regular double, it's huge. But when you integrate this into the actual systems and the surroundings and the rest of the envelope, it's not that great. So we showed to them that they could use the same budget, use in other techniques, in other methods to actually get better performance. And triple glazing, in this case in particular, wasn't the way to go. So again, you need to integrate everything together, and that's why we have experts in everything. We have experts that do thermal analysis. We have experts that do engineering. We have experts that do all the waterproofing, all the detailing. So we are all integrated and we perform everything in-house. We don't sub anything out. And we can do it all: engineering, design, drafting, everything. So just reach out.
So many benefits, yeah, so many benefits. Awesome. No, on that, naturally, you're saying the other way around, actually, in terms of the climate change. So interesting one, but how do we keep sustainability in mind when considering facade engineering?
Yeah, so we have seen over the years that there's some building owners that are pretty concerned with the performance of the buildings. Some of these concerns are driven by the overall energy consumption and the bills, right? Because like operating the building costs money. So they look at it, some look at it in a cost benefit type of way. So if they were to pay upfront for this much or better improved systems, how long would it take for them to get the money back per se? Some others, they really don't care. Some others, they just say like, this is my budget. I'm gonna sell the building in 2 years after it's completed. So they are not necessarily concerned with the overall performance because it's not going to be their problem anymore. So what we have seen that it's that legislation has helped drive this car. And it's only there where if some, I mean, again, some are genuinely concerned, but some others are not. So the ones that are not, if it's a must do per the legislation, then they have to do it, and there's no way around. So if you look at the evolution of building codes, the building codes have every single edition have been more strict and strict and strict. So as the years go by, there's a lot of focus and attention being paid to thermal performance and air. So the codes are helping drive this for sure.
Which is awesome, which is really good. Yeah, I think it's really important to keep in mind. And I think you're so right. It's interesting. I would say we're at the precipice, right? Where states like DC and potentially New York, who are more eco-conscious, we will be seeing this more and more. Other states that potentially just don't care as much, and it would, the repercussions of that. Okay, no, interesting. And sort of we've touched on it, but what do you think facade engineering will look like in the future? What are your predictions, kind of thing?
I think it's getting more specialized and harder, which is good because it keeps things interesting for everyone that it's doing this every day. But I think it's it's gonna get more strict. So the industry also we're gonna have to get more keen and smarter in finding ways for systems and the overall envelope to perform better. So I think that in the near future, we're going to see systems and performance that everyone thought it was going to be impossible to get to 10 years ago. So I think it's heading that way, performance-wise, and thermal performance is what's driving this.
Oh, interesting. No, people have to keep an eye out for the challenges and their problem-solving skills, right?
Yeah.
Love it. Well, I guess on that note, that was a brilliant summary of facade engineering and an incredible introduction to yourself and CDC, who absolutely, we've partnered with for a long time and really, really enjoy working with. Thank you so much for that, Vicente. It's been a pleasure.
Thank you, Sarah. Thank you very much.
Awesome. So stay tuned for our next installments in the series, where we'll be touching on restoration engineering. We'll take it from there. Thanks, guys.